you want to start? Or? Yeah.
Okay. Hi and welcome everyone. We'll start. Yeah, we could start now. Ahead of schedule. Not always like that. I'm Lucas Kjellström. I'm the CNCF ambassador in Finland and helping organize these Finnish events and grow our community around CNCF and Kubernetes topics. And really glad that we're all here today. And Jussi and Oliver helped a lot with finding this space and all the sponsors and stuff. So yeah, we have had, I think, 6 similar meetups in Helsinki the latest years, and now we're growing and expanding into Tampere, hopefully in some other Finnish cities in the coming months and years as well.
Hi, my name is Oliver, and I just want to tell you about how I got this idea of creating this group. So, well, of course, I'm an application developer, and I have worked with containers quite long. And I visited KubeCon in Copenhagen, and I think there I understood what CNCF is doing, and I thought, okay, this is a great idea, and let's check if there are meetup groups in Tampere, but I couldn't find, so I checked in Helsinki and I found Lucas' group there. I went there and reached out to him and proposed the idea, and he was a bit skeptic in the beginning, maybe, but then a bit. And well, otherwise it worked out quite fine, and we are now all here. Really great to see you. Welcome. Jussi?
All right. So I see a lot of familiar faces, so I'm not going to talk about myself that much. But yeah, my name is Jussi. I actually kind of almost stumbled on the empty group that Lucas created like November or something. I think we met in November or something. Yeah. And I contacted Lucas and okay, I've been working with containers and Kubernetes for a while, as many of you know. So I can help organize these things, and yeah, that's how we got things started.
Mm-hmm.
And we are here. Really glad to see so many faces around here. So yeah, I guess Lucas will continue a bit on the CNCF part, and we'll go from there. We have a lot of good presentations upcoming this evening, so join the ride.
Yeah, so we'd also like to thank our sponsors. CNCF is sponsoring today, as well as Cybercom. Thanks to them, we can be here. Nedum is also sponsoring with this meetup, and yeah, if you take the next slide, we have there are different forms to contact us and to help expand this group. Yes, we're helping organizing stuff and similar, but we'd really like to get you involved and to get you active, talking about this, organizing your own events, helping the community in various ways, writing blog posts, etc., etc. So I'm helping organize this kind of alliance of meetups in the Nordic countries here. That is in progress now, so we're expanding the Finnish groups, but also trying to coordinate with the Swedish, Danish, and Norwegian groups. And that's really exciting. We will try to aggregate all the material in this GitHub repo in Cloud Native Nordics /meetups. Also, we have like great unified whatever Slack channel for the Nordic meetup groups as well, which you can sign up. I realize we didn't put it here yet, but cloudnativenordics.com. We can add it later. As said, yes, these are recorded, and there are also recordings from the earlier meetups in Helsinki available at this YouTube channel. We have, the way we do it is like we have this Kubernetes Finland meetup group, which is announcing all the meetups in Finland, as well as the ones in Helsinki. And then we expand to, as we expand to multiple cities, we create different Kubernetes Tampere, Kubernetes eventually Turku, Oulu, I don't know. It depends on your involvement as well, because we can't be anywhere, everywhere. And yeah, here is how to contact us if you want. And for future meetups of this kind, we're always looking for speakers, always looking for lightning talks or whatever discussions. And yeah, we usually have in these meetups so that we provide, well, we have a venue sponsor, which we're glad to have, and that venue sponsor gets 5 minutes about to talk about their company and stuff, and after that we continue with the regular talks. And if you could take back to the agenda, we'll quickly look, so that we'll have this introduction words from Cybercom. I'll do the intro on what CNCF is and kind of why we're all here today with regards to Kubernetes and other tech. Then we'll continue with Jussi, who's going to talk about the Kubernetes setup and things like that. And then end user storage, which are really valuable and appreciated. We always welcome end user stories on how they've taken these new approaches into the production and what has worked and what maybe didn't work. And that is really, really useful. And we'll end this with some networking time. Okay. No. Cybercon.
So one of the kind of members of the organizing committee is actually missing. So just wanted to mention Sakari Hoisko from Eficode. He had some important family things, so he wasn't able to be here.
Yeah. Yes.
I'm kind of the replacement Sakari if you have something.
Okay.
All right. Yeah, he mentioned it today, so we'll give all the nuckies to you.
Time use to reach out to us, because we are really interested how we can do this better. Is it starting too late, or do we need more speakers or less speakers? So please come and talk to us.
And tweet to Kubernetes Finland.
Yes, please. Okay, Tony.
Yeah.
Thanks.
Maybe if you just switch back to sponsoring slides, maybe.
Okay.
I had mine, but that's same.
Okay.
Okay. And this one.
Yes.
Okay. Just a sec. Okay. Hello all, and welcome to our Kubernetes meetup, as they just introduced. I'm Toni Ylenius. I represent Cybercom in this meetup. We have maybe 5 or 6 of us here, and just first about the practicalities. So if you have anything about questions about the event or the venue, then you can ask from me or Santtu, who is just photographing, or also Esa, that is somewhere here. I mean the other is Oka, of course. You can also answer, but we also have Esa Heino. That he will arrive soon after letting us in. But yeah, the fourth one is the Esa there, and I don't know if Santtu already introduced, but the closest toilets are just beside the kitchen. And also all the drinks, and I don't know, maybe there are not that much food left, but that's also in the kitchen. So, about Cybercom. That's a Swedish company. We do, for example, media. We work with media. I mean the stuff we have been working, that's started working with media, for example, Iltalehti, MTV. But nowadays we also, We do a lot of cloud things like AWS, and then we also do a lot of work with public sector. And why I am here? That's because we in Tampere we have a lot of, we could call open source competence, because we have had our own data center here in Tampere. So we have a lot of so-called Linux people here. And nowadays Kubernetes is just the manifestation of this Linux competence. Just a moment ago it was OpenStack. And we also worked heavily there. And the thing I'm looking here is, of course, that as all the IT companies we are hiring, and if you have any, if you are interested to work with Kubernetes and open source things, please contact me. And of course we have the career site where you can check the things we have. Yeah. Maybe this is the quick introduction. Santu, did I miss any practical things?
No, we're good.
Okay, thank you. And maybe just as one special mention, because you saw all the three original organizers, and also the Sakari, if I or this, yeah. Then I would like to give a special thanks to Oliver, because basically he has been the one that has been pushing this thing forward. So yeah, let's give a thanks to you. Yeah. And let's have a great meetup. Who was the second one? Or the first?
Lucas.
Yes.
Lucas is the first.
Yeah. Thank you.
Thank you. This was yours.
No.
Yeah.
Let's see if this works. Should I use your computer or
You can go.
you should?
I think we
Yeah.
have.
Yeah, that looks like just a normal presentation. Thank you, everyone. And yeah, I'm going to do the introduction for what is CNCF, what is Kubernetes, and why are we gathering today. First, a bit of background for myself. I just graduated from high school, and I'm right now doing my military service, which you can see from my boots. I'm very grateful that I got to do this evening off and come here from Draxweek, where I'm doing my service at the moment. I've been doing the Kubernetes thing for 3.5 years or so, and Kubernetes is 4.5, I guess, now. And been talking at 5 different KubeCons. Been a really nice, it's been really nice to see it growing from like 1,000 in Seattle 2 years ago to now 8,000 in the latest conference. That's just amazing, and we want to continue building the community in responsible and healthy ways, like this. I'm then the CNCF ambassador, which is trying to expand these communities and organize these events. And yes, as previous speaker said, we need these kind of champions for the local areas. So Oliver has been helping a lot here to champion this in Tampere, because, well, I'm in Draxweek, so can't do much things locally. But yeah, I've been working on Kubernetes for a while, and I'm driving my consulting company as well. That is basically doing Kubernetes upstream contributions and consulting for like companies and whatever internal Kubernetes stuff. And at the moment I've been contributing 2 years on behalf of WeWorks, which is in London. So I can focus totally upstream, make Kubernetes better in great different ways. For example, I created KubeADM together with a lot of other awesome folks, and we now got it to GA. So why or what is CNCF? Why are we here? What is CNCF? Compared to some other projects out there, CNCF is trying to do the open source cloud computing. Like cloud computing is really generic, and there's loads of stuff in there. First, scope it down to open source, and then think about focusing on the applications, not the infrastructure, which is really the key point here. Is we don't necessarily think that much about the VMs or whatever. We focus in CNCF projects focus on the container parts of this, or the container is just the delivery mechanism, but the application parts of this. So what does CNCF do? Well, they host a lot of projects. They help these projects succeed. We have 3 graduated projects. We have about 15 or something incubating projects and nearly 10 more sandbox projects. And there are large sponsors, the platinum members you can see here, which are definitely the largest companies in the world, in the tech world. And why does CNCF have these different levels of maturity? Well, they want to signal to their end users how and when you should adopt a specific project. And this crossing the chasm is pretty well known. And basically the sandbox projects you can see here is really the first alpha stages of an exciting new technique. And then as that thing matures and starts getting production users and all that, getting the community behind it, as an open source project, we get to the incubating stage. That is promising tech, and it's proven to work in production scenarios. And then when we get over the chasm, the project in CNCF graduates, and that means now now it's like mainstream. Now this tech is actually a thing everybody uses, like Kubernetes or Prometheus, very well-known projects. Why does CNCF exist? Well, you're an end-user company. You want to start your cloud-native journey, and you don't even know all of these, like, you don't even have this picture. You just know that there's a lot of stuff out there, right? A lot of stuff is good. A lot of stuff is okay. And something maybe doesn't at all work for your environment or requirements. So CNCF is putting together this cloud-native landscape, which is overwhelming still. Now we at least have it on a map. But then we have the technical oversight committee of CNCF that is picking good, high-quality projects that, well, the projects themselves apply to become a CNCF project, but still, they choose here the ones you actually can rely on in your mission-critical software or software solutions. So then, as an end user, you have a better idea of, well, I can actually use Kubernetes in production because that's proven to work, or it's pretty okay to like adopt Prometheus for my monitoring system, or whatever. And as part of this, they also also have some certification programs and stuff. We'll look in a moment. But put simply, non-profit organization that makes everybody come together in a neutral place. And CNCF is part of the Linux Foundation and promotes this toolkit of trusted projects. And when they get there into CNCF, CNCF helps them succeed financially, but also with regards to the community. For example, making it possible for people to organize these events, help them do the KubeCons, etc., etc., etc. As part of the landscape, CNCF also has this kind of trail map. So once you're on your journey, you know where to start. So first of all, containerization. Before you start thinking about runtimes or streaming and messaging or software distribution, you should think about, okay, do I have my stuff containerized or a similar thing? And once I have adopted that kind of thing, then I can think about, or CNCF thinks it's good to think about continuous delivery and continuous integration, and at least have some kind of solution for those problems or patterns. Once you're there, you might want to think about, how do I run this on multiple nodes in a reproducible manner, in an inspectable manner, in a predictable manner. Then we get to Kubernetes and start doing observability and stuff. So CNCF tries to help you with this as an end user. I'm not going to read it through, but here we have the like official whatever cloud native description for those who are interested. But it's kind of these things that I've touched on. Doing things in a scalable, dynamically orchestrated, and more microservice-oriented manner for loosely coupled open source systems. So CNCF also helps with things like certifications. So now you can know, for example, we have two of them at the moment for Kubernetes, Certified Kubernetes Administrator and Application Developer. Application Developer is basically a subset of the Administrator one. I'm a Certified Kubernetes Administrator, and as well as many others. They are there you basically at the console in your hands, and you get a couple of like 40 or whatever it was, now maybe 30 tasks to complete in a whatever time frame, and then you actually do as you would program in a real world environment, and that's then graded. And in order, if I am a vendor of Kubernetes that sell Kubernetes as a service to my end users, the end user wants to know, does this vendor actually like do it the right way? Because Kubernetes is such a complex system, and as any distributed system, it kind of gets messy at times, and like there are 6 components in Kubernetes or whatever, and primary 5, and every of these components have like 100 or more flags. So how do we know that the vendor has configured them properly so that it works as expected? Well, therefore we have the conformance program, and CNCF is helping facilitate this, so that every vendor can run the set of conformance tests that are bundled with Kubernetes and upload them to CNCF, show that my solution is actually conformant to the specifications of what is Kubernetes, what is the baseline of Kubernetes functionality. And hence you get this mark, and if you as an end user see this, you know that, okay, it at least has some kind of compatibility with others. And here we have already 75 certified Kubernetes offerings. And this program has been active for like about a year. So that's really nice. If you are a company, you also have the certified service provider thing. So if you have 3 or more of these CKAs, certified Kubernetes administrators, you're a CNCF member and you have a good business model to support your users of Kubernetes, you can become this. And again, get benefits as being listed as a Kubernetes partner, stuff like that. So Kubernetes CNCF helps with a lot of these meta things that are really critical to the ecosystem in the long term. And events are a big thing. Next year we have one in Europe in the spring, we have one in the summer in China, and one in North America in the winter. These dates, you can check them out later. But just to give you a, yeah.
Go back one slide. So just a note, if you wanna submit a paper to the Europe coupon,
yeah,
it's gonna close tomorrow at 9 a.m. I know because that's my deadline.
Yeah, I still have to actually click on the button. But yes, in Barcelona is coming up real soon, and you can already buy the tickets and all that kind of stuff, but also submit proposals if you want. And to give you an idea of how this has grown, as said, we were about 1,000 2 years ago, the first one in North America that CNCF organized. Now, last one in Seattle a month ago, we were 8,000. So, and CNCF is expanding in multiple regions. There's a Kubernetes India Day in this year as well, and etc. So, yeah, it's going to be interesting to see how this grows. Okay, so now we'll move on to Kubernetes. What is Kubernetes? I mean, I've already talked about it, but more the meta things, not the tech. So what does it mean? People ask kind of often. It's Greek for pilot or helping of a ship, which kind of makes sense once you understand how Kubernetes works. And if I would describe it in one sentence, I think this is also what it says on the GitHub description: a production-grade container orchestration system, which is might or might not say things to you, but let's check on a bit on the history about Kubernetes. It's Google grown. 4.5 years ago, they developed the next version, the third version of Google's own containerization and orchestration systems. Borg and Omega are the ones that are actually powering all Google services today, and Kubernetes is supposed to be the next generation. But they did a critical decision and decided that the third version is going to be open source. And this sparked all this, and Kubernetes is now one of the largest open source projects in the world. Google is obviously like a very huge user of containers, and they've done so for like soon, or like already 1.5 decades. And it was CNCF seed project. A year after it's open source, a year after it was open sourced, it got donated to CNCF, or like it released its first production version, 101, and also got donated to CNCF. The last version was 113 and came in December, and now every 3 months there's a new Kubernetes version. But what does it actually do? Well, as an end user, if you have a lot of hardware, if you have a lot of compute, it tends to get messy once you SSH into the 1,000 computer on your working day. Then you're kind of tired, because the first one have already been broken by that time. So you want something that abstracts away the hardware and lets you think about the application, like this more higher level tool and or platform. And Kubernetes lets you do that, and you can think of it. Some people like this analogy, some people don't, but I'll tell it anyway. You can manage your application more like cattle versus pets. So instead of going and actually SSHing into all the machines or whatever, doing things imperatively, you start doing things declaratively. And that's a very important shift. So you do these bulk operations and you tell Kubernetes how things should be in the ideal world. And then if you start thinking about it, Kubernetes becomes this Linux for distributed systems. So you're not writing assembly today when you're writing your code. Because then you would like have to do things for this computer and this computer and this computer. Instead, you want something like, okay, I want an abstraction layer over the CPU and over the hardware, rest of the hardware, and let me write things towards one set of APIs that then translate stuff into the actual CPU, into the actual whatever hard drive you have. And once you start to think about it like this, Kubernetes becomes the Linux, but for distributed systems. So you have a set of nodes, whatever size, kind of, and now you say, I want this application to be run in this way. And I want this to be this application, I can express its dependencies on things and how it should connect to other services. And now you don't actually care about if it's running on node 1 or 152 or 9,322. Because that's just the implementation details and the runtime details. I'm just interested in the way it should be. So the administrator to Kubernetes says this is the desired state, and Kubernetes' only job is like to reconcile, to wait, check, is the actual state the desired state? If it is, well, then good. I'm gonna go sleep for an hour, and then check again. Is it still the case? And if not, I'm gonna fix it. So one important thing to know though about Kubernetes is that it might or might not be suitable for your business. And that is because of key design decisions. And also due to how to scope things. You can't fix everything for everybody. So you have to set some limits, and you have to set a scope for the project. And the scope for Kubernetes is to do this abstraction and to be extensible. So you can build the higher level abstractions you want. So to say this in more in another way, you could still think about Kubernetes as a low-level language, and then I'm going to show a couple of YAML files here. And doing syscalls to the Linux kernel might be a thing you want to do, but you might also want to have something more higher level, in the same way as writing YAML, writing raw Kubernetes objects, and running them, like using Kubernetes directly, might be a thing you want to do, but you might also just want to have something more higher level that focuses on your business needs. So that means Kubernetes is a platform. It's a platform to build more platforms upon. So if you have any high-level platform, still have to do the very hard implementation details of how to become a distributed system. But Kubernetes abstracts and unifies this into one set of APIs. So on those well-known stable APIs, you can build your higher level solution that is exactly suitable to your business needs. That's why Kubernetes has so many extension mechanisms, and that's why there's so many companies that are building higher level abstractions on top. That's also why we have the conformance program, because we still want to make sure that everybody's on the same page, although having extra add-ons. Here is a graph of how Kubernetes is doing in Google search, and I would say it's doing pretty well. You might or might not agree, but this is some raw data about Kubernetes and its community. It's kind of amazing to see that this, and also notice that this, the commit stats and all these things are from the last year. If we would aggregate from the beginning of Kubernetes lifetime, we would have even larger numbers. But just consider the thing, or the fact that we have nearly 320,000 comments on Kubernetes repositories in the latest years. That's like 1,000 comments per day about, and that means people are working on it all the time, 24/7, all around the world. We have 55 users on the Kubernetes Slack channel. This is growing, like every time I update this presentation, it's grown by a couple of thousands, even though I do them like every month. And a lot of open issues. There's now a lot of people actually around the world that put Kubernetes on the LinkedIn page. Apparently 88,000. Nearly half of that, we have Kubernetes job applications on LinkedIn. There's a free course from Linux Foundation on edx.org that has already got more than 50k enrolls. And this goes on and on and on. But a key fact is we have 15,000 contributors in the latest year that have been in some way involved with the project. Been helping with code, been helping with PR reviews, or creating issues, or project management, documentation, whatever. But still, 15,000 is quite a significant number. So I'm going to quickly go through the basic concepts of Kubernetes. So that atomically deployable unit is a pod, and this represents a single instance of an application. And here we express it with a web server. We say we want a pod. Its name is Nginx. And the specification of this, the desired state, we say here. And the desired state is to run an image that is Nginx of this version. And the desired state is to expose a port on 80. And it's important to note that pods are they are mortal. They are scheduled on a node, and if that node goes down, the pod dies. So that's why we need a higher level thing than pod, that is deployment. So we say we want a deployment. The desired state is to have 3 of this template. So we have a template for a pod, and we say I want 3 of these every time. And we could say I want 10,000 of these, and Kubernetes will make that happen, obviously if there's compute available. And as we update this specification here, Kubernetes is going to do a rolling upgrade to make sure the desired state is the actual state. And this is very declarative, and that's the thing. So this is the kind of strategy that Kubernetes uses by default, but using custom code, you can implement whatever strategy you want. And then if you have 10,000 different pods running at their own IP addresses across the cluster, you want to have some kind of way to express, I want one stable identity for all the workloads that are running. And you do that via a service. So a service is exposes one or many pods endpoints through a stable and immortal and internal IP address. So the key thing here is the service has a selector, and it selects all pods with these labels, with these key value pairs. So going back, we see that a pod in the metadata, we've specified one or many labels. Then we select them in the service. That means we can have any kind of topology we want. and here we define how one or many ports, and also this service is reachable through internal DNS. And then when you want to expose this to the world, you create an ingress, which is a claim to expose this to the world. You then have some kind of ingress controller, like Trafic, or there are many others, that make this happen, but it's a claim that my service, which is here, should be exposed at this URL, and then have some controller making that happen. So in the end, it might look like this. We have the internet, we have a domain which points to some kind of externally available node, and there we have some kind of load balancer which is running, and then can proxy things to the cluster. And we have n workloads that are running. You can just set the number through this deployment, and that's matched and load balanced by this service. And all this is happening inside of a namespace, which is a logical isolation method within Kubernetes. So you can group between teams or between environments or whatever. And I have role-based access control there. So gonna have to finish this soon, but how can you get involved and how can you get started? Just a couple of resources. This is gonna be available in the meetup group soon, but you can check these links out as part of that. If you're starting on your local computer, you might want to start with Minikube if you have Windows or Mac. But if you're starting on Linux, or if you want to create a production ready cluster, you might want to use kubeadm, which I'll show in a moment. Kubernetes in Docker is also another solution. And with kubeadm, you can create a cluster as easily as this. You have your machine booted up with whatever Linux OS. You install Docker, some kind of runtime, and you install kubeadm from the Kubernetes apt repositories. You run kubeadm init, which is giving you a master. And you then apply some kind of pod network to make the network routing between all the nodes in the cluster possible, because that is external. Kubernetes has many extension mechanisms. And if you want to join the second node, you can just run kubeadm join. But this is the minimal viable way of how to create a Kubernetes clusters. As I said, there are many others that are doing more higher level things. So you can specify, I want a cluster in AWS, and then this provider will just go ahead and make that possible. But this is like the minimum viable thing you can do, and it's also a thing that many providers themselves wrap. So they use kubeadm internally and then expose some other user interface. The Kubernetes is a large project, so it has many different special interest groups and working groups who are targeted at specific problems. These meet regularly, every week, every 2 weeks, and they have recorded meetings. They go up on YouTube. They are public, anyone can join. And I myself, I'm leading the cluster lifecycle one, where we think about how to install, how to upgrade, how to manage Kubernetes, how to set it up. And here I've got all the links for you if you're interested later. If you want to start contributing to Kubernetes or get in touch with the community, you can follow this 1, 2, 3 list. And if you want a more comprehensive, this was really fast. I apologize if I went too fast. But here we have a 182 slide workshop presentation, which you can check out with all the stuff. Obviously, the Kubernetes official documentation is available as well. But I would encourage you to join the community in Barcelona, Shanghai, or San Diego next year. Thanks. Shall we have a short 5-minute break or something?
Yeah.
Yeah.
So short break, grab some drinks, do whatever you need to do, and we'll continue in 5 or 10 minutes. Actually, have a demo. I'm going to demo Yeah, so I'm gonna give a few words about how to get started with the kind of path towards being cloud native and especially how to get started with Kubernetes. So for those of you who don't know who I am, so I'm still Jussi. But I work for a company called Contena, and with Contena we've been building container platforms, container-based solutions for quite a few years already. I've been with the company almost 3 years. Previously working many places. And I've been working with the containers and microservices for almost 5 years already. So I actually went to production with Docker 0.6. It was a really bad idea. But that's another story. Seeing the kind of cloud native trail map kind of reminded me of one of the kind of ideas that we had for the meetup group itself. So we're gonna at least try to get presentations on each of the meetups from different stages of the trail. So in the first meetup, I'm presenting how to get started with Kubernetes, so which is one of the first things on the trail. So we're gonna kind of skip the 1 and 2. Well, most of you are probably on containers already, so so we'll skip them and head straight to Kubernetes. But let's see how it goes. But that's at least the idea for the meetup group itself. And also from the getting started point of view, a reminder that what Lucas also mentioned, that Kubernetes, you should really think about it more like a Linux kernel. So if you take the plain Kubernetes open source project, you get something that's similar to Linux kernel. So probably none of us in the room actually goes and compiles your own kernel and builds stuff on top of that. I mean, if you do, then you probably have a pretty sophisticated and niche use case for that. Most of us just take Ubuntu or CentOS or something and we're happy about it. So Kubernetes is definitely not the end game itself. There's a lot of solutions, a lot of high-level solutions building on top of that. So, but we'll start with the basics still, of course. It's important to understand what happens actually in the kernel, same as in the Linux world. It helps immensely if you understand what actually happens in the kernel, at least on some level. Yeah. Probably some of you remember these books. These are really cool, or were. I'm not sure if you can actually go and buy them anymore, at least not from the corner store. But I think actually when you kind of start your journey into Kubernetes, it pretty much feels like these fancy adventures. And unfortunately, as in these, after some of the choices you make, you end up being eaten by a dragon. Or as I remember when I was a kid, one of my friends had one of these books that was based on some galactic adventure or something. And I always ended up in a black hole. So it might happen to you also in your journey to Kubernetes. You really have to ask the biggest and most important question first. Do you really need Kubernetes? I've seen people starting to use Kubernetes because, well, I want to run things on containers, so I want to run things on Kubernetes. Okay, what do you run? Well, I have one WordPress container. Yeah. Then ask the next question. Do you really need Kubernetes? Well, we'll continue then. I mean, you see these things happening It's and of course it's not with Kubernetes. It's basically with any new or newish technology. So you might end up seeing a Kubernetes cluster with one WordPress container. That might be fine if you want to play around with Kubernetes. Well, if you kind of figure out that okay, you are going to run on some scale, you really need containers and container orchestration to give you the flexibility, declarative deployment of applications and so on. You really have to kind of then start your questionnaire and try to find the correct path for you. So do you want to build it yourself? I mean, the platform, Kubernetes. Do you want to set it up everything yourself by yourself? Do you buy it? And by buying, I mean taking some higher level solution that sets up the complete platform plus expert for you. It might be open source, so that's why buy is there. Or can you actually go and rent it? Like if you have a need for a car only for a single weekend for a year, you probably go to rental. Right, you don't go and buy one just because you have to use it once in a while. And of course, where, how, and by whom you're going to run it. What's the environment? That makes a lot of difference how you build up the platform. What's your threat model? Do you expose random services on internet? Or do you expose services internally in your company or something else? Those affect highly on the choices you have to make on the platform. And also what's your availability model? Do you really want to have like 7 nines of availability? Which probably means you have to scale the platform across different cloud providers, across different regions and so on. Or it's okay if the service you're running is down for hour, couple of hours every now and then. You can run it on your Mac or something. Well, not on Mac. You get the point. Alright, so doing things yourself, it's always kind of fun, right? If you really want to kind of dive into the do-it-yourself part, check out the Kubernetes the hard way. Hit it with Google and you'll find Kelsey Hightower's GitHub repo. So it basically starts by spinning up computers on Google Cloud, installing packages, configuring every single piece of thing manually. So I think there's, Lucas probably knows it better, but I think there's like 14, 15 pages of kind of phases in the instructions. Yeah. So it's a really nice way to learn how these components and things fit together internally. But you probably don't want to do it that way. But it's created for learning purposes and learning purposes only. So I think there's a statement that do not use these configurations in production.
Yeah, it's like that. But that's why we built kubeadm to codify all those.
Yeah. Yeah. And as I said, kubeadm gets you started pretty nicely. And with proper configurations for kubeadm itself, you can actually get production ready clusters with kubeadm. I'm going to show, well, not production ready, but a cluster created by kubeadm in a demo. Then we have these buy options called distributions. So, as I said, think of them like Linux distributions. It's the kernel ready compiled plus a lot of things that make it actually usable. There's 14 open source distros available. One of them is ours. And like Lucas mentioned, there's, if you count also the non-OSS ones, there's like 40 something.
70.
70? Okay.
Alright.
Yeah. So it's more like a pre-packaged Kubernetes plus typically Express And with extras, I mean things that you always still need on top of your base Kubernetes. I mean, as Lucas mentioned, Kubernetes basically takes your pod YAMLs and runs them on the cluster. But you really need more than that. You need certificates, you need storage, you need this and that. So that's where the distributions help you a lot. And they typically provide end-to-end management also for the whole life cycle of the cluster, and only bootstrapping it easily, but upgrades and everything. But of course, if you're already running on the cloud, kind of married to a cloud provider, take their solution. It's easy to rent out, you don't have to worry about the nitty-gritty details. Just shoot your YAMLs and you're good to go.
And it's often free as well. It's like the Kubernetes part.
Ish. Yeah. Yeah, the Kubernetes part is free, but yeah. You have to have resources to run your pods
Yes,
then. And
yeah, obviously.
so, yeah. I wouldn't call it free, but yeah. Pretty much all the cloud providers have solutions for Kubernetes now. I think DigitalOcean was the last one of the big cloud providers to have a offering on Kubernetes. And I think it's still on beta label.
Yeah.
I think at least not on GA. I've been trying the beta for a while. Seems to work pretty okay.
AliCloud in Singapore from that list. There is also.
What?
AliCloud.
Yeah, probably. That's why there's 3 dots.
Yeah.
So all of them have something.
I have used it.
Okay. Okay. But how to get actually started? I mean, really in practice get started. So as Lucas already mentioned, there's Minikube. That's easily runnable on I think it works on Windows too. I haven't tried it, but yeah, I see a lot of people noting. So yes, Minikube is decent way to get started. And now Docker for Mac, Docker for Windows, they also have Kubernetes. Seems to be pretty okay. They actually both suffer the same feature, that when your Mac goes to sleep and then you open it up again, the API server takes like 30% of my CPU.
Yeah, and let's say that Windows stuff need that Hyper-V.
Yeah.
So it means that you need Pro or Enterprise licenses for Windows.
Alright.
And let's say that Hyper-V is pure C.
Alright. Okay. But as I said, it's really easy to get your hands dirty also with these hosted Kubernetes from Google, Amazon, because the kind of cluster itself doesn't cost you probably anything. The cost actually depends on how much stuff you run on top of it, how much resources you need under the cluster for your actual applications.
How much extras you buy.
Yeah. Yeah.
To take that back that cost in load balances and whatever, and that are overpriced.
Yeah.
So
Yeah, but you can get really easily started and kind of dip your toes in the water and kind of get your hands dirty. Because I think you have to do this before you actually know whether you really need Kubernetes or not. Because there are a lot of use cases where you actually don't. If you have a handful of containers, you don't need Kubernetes. There are easier ways to do it. And then evaluate also the distributions, because, well, as I said, there's many of those. They have different flavors, they have different kind of features, they have different target environments. Some are targeting purely cloud providers, some are targeting on-premises, and somewhere in between. So there's a lot of different options. Evaluate those. But still, you have to kind of think about also the day-two problems a bit. We're not going to go dive into this too much today, but maybe in a future meetups, kind of traveling the path, we'll see presentations and demos on these two. So you still have to have backups. Kubernetes is no silver bullet. I'm sorry, it's not. It's a fancy tool, yes, but it's not a silver bullet. You still have to maintain it. You still have to upgrade it, and so on. These typical problems that you see day to day.
And probably security is one of things what you should be added there.
Yeah.
How to implement things so those are secure.
Yeah, that's a big thing. And there's also this thing, problems, but I kind of, at least in my head, think about like day 3 problems. Kubernetes is it's not a simple tool. So it's a highly complex tool, and I kind of promise that every single one of you is gonna shoot their own leg off with Kubernetes. I've shot mine off quite a few times already. One of the critical things, kind of also emphasized on the cloud native trail map, with the start of having containers and having CI and CD processes in place. It's highly important also with Kubernetes. I mean, you're not gonna see any benefits unless your processes and other tools are kind of aligned with the same goal. There's actually just like yesterday or day before, there was a really nice discussion on Reddit about an organization who, but the manager basically said that we're spending a lot of time, money, effort, coffee with Kubernetes, and we're not seeing any benefits. I highly suggest to read that from Reddit. It's only from a couple of days ago, so it should be findable. And one of the problems I've seen quite often with people starting with Kubernetes is a thing called tech invasion. Now you have this fancy Kubernetes where you can run anything easily. What do developers do? Well, they run everything there. You want to have your own application, then you think, oh yeah, there's this cool thing called service mesh. Yeah, let's put it in. There's open trace. Oh yeah, let's put it in. There's XYZ. Let's put it in. I want to have it. Suddenly you have like 27 different layers of things which nobody actually understands. So don't do it. Start with easy things and grow from there. All right.
How you see example HDF? How ready it is, and is it that easy thing or not easy thing?
It's not easy thing.
Yeah, I think so same.
You cannot have service mesh and easy, not even in the same city.
Yeah. Let's say that hopefully we can get here also some presentation about HDF.
Probably.
It's quite cool, but
Yeah,
where and how?
yeah, and that's the problem.
And when?
Yeah, that's true.
It's the technologies around Kubernetes, around containers, around this whole CNCF landscape. The technologies are cool, but again, ask yourself the question: do I really need it? Am I tall enough to write it? I mean, everybody knows Herkaniemi. Are you tall enough to go to the devices? Because I've been saying this with microservices for the past few years. If your organization plans to do microservices, you should also do this. Am I tall enough to do microservices? Because it comes with a lot of baggage. All right. The demo. How much do I have about time? Enough for... I have enough time to spin up a Kubernetes cluster. No. Yeah. So what I've done already, I've used Terraform to provision a couple of nodes for me on DigitalOcean. Nothing special, just plain old Ubuntu boxes. SSH, root, yeah. These are for demo. I did say that I'm not going to do a production-ready cluster, even though I could with KubeADM, but I'm not going to do it. So, plain old Kubernetes, I did run a helper script to get all the Kubernetes packages already in place, so we don't need to wait for internet. Because, well, as you know, that sucks.
Yeah. But it's a font a bit larger, please. But with regards to the packages, it's like just a normal add Kubernetes app repos and
Yeah, the usual stuff that you do.
yeah.
Anyway.
It's not that interesting.
Definitely not. Yeah. So KubeADM init. But yeah, actually we have to wait for internet for a while. But I forgot to. Yeah. I always forget to do it. So KubeADM init, what it does for me, it spins up the control plane, which basically means that there's quite a few different components. It generates all the needed certificates and everything, so everything is set up by default pretty securely. Not as securely as you can do it with further configuration, but today it's pretty secure by default. It spins up etcd, the database, where the desired state lives, and the actual state, or the last known actual state lives also. And scheduler, API server, controller manager. That's about it in typical setup.
Kubernetes and proxy.
Yeah,
DNS things. But yeah, I realized I didn't show the architecture diagram. I accidentally skipped it, but I can show it afterwards there, because then you get a better understanding of what the different components are.
What if I show it because I have it open? No, go away.
Alright. So, the control plane is basically there. What I have to do, because I have two nodes that I'm going to use, I have to get some networking between the nodes so that my workload containers can actually go and find themselves. I have a comment here ready.
So, wow. Export.
Yeah.
Thing there is, you need to, because it's set up securely, you need to say the kubectl, the Kubernetes client, where do I find the certificates? In which file do I find the right certificates with the right permissions to find the right API server to talk to?
Yeah. So now I'm gonna just shoot away a YAML definition for my networking. So I'm in this demo I'm gonna use Weave. So now I have a node in a role master which is not ready. I guess we're waiting for some pods. Yeah, now it's ready. Alright. Let's scroll back a bit because kubeadms spits us out a really important command. So this is a command that I can use on my worker node to connect the worker into the cluster with the master.
And it was really interesting to write this piece of code, because you need to establish, as well as like any other software, bidirectional trust. So that's why we have the token. It works as both the authentication mechanism from the node side to the master. Say I'm the one you think I am, but I also, as a node, have to verify that I'm joining the correct master, that I'm not being man in the middle and joining a random API server that I don't trust. So that's why we have that. It's short enough to copy, but still long enough that it's secure.
Yeah. So now the worker is part of the cluster, not ready yet. Well, it's pulling images. So in every single demo that you do today, you're waiting for Docker or something to pull images. It's really not so cool, but yeah, we have to live with it. So once it pulls all the networking components into place, it switches to ready, and that's my cluster. Almost production ready. Not really production ready. There's a few security things that I would do in a typical production ready cluster, like encryption for the secrets and those sort of things. But it's close there. So simple as stealing kids from not kids, candy from kids. Yeah. Stealing candy from kids.
other one and I keep bring my body.
All right. So this is something else you can also in this meetup group. Bad jokes. For free.
And we got it on tape.
Yeah. Yeah. But yeah, KubeADM gets you started nicely, but then there's other solutions to get you faster, more secure, easier, and so on. But it really, you have to think about the path that you're starting on, and not just head on full speed. That will get you in trouble fast. All right. Thanks. So again, 5-ish
Short
minutes break, and then Ilkka will continue with their journey.
Jussi, when we will see demo how to do the same with the cars, because it's easier.
Yeah, so, hey, hi everybody, I'm Ilkka. I'm gonna give you a little look from the user's point of view, as Jonas said. So, sorry, Lucas, about migrating a service that we built from Heroku onto AKS, or the Azure Kubernetes service. A few brief words about myself. I work for Features, which is a Finnish consultancy now spread a little bit more throughout Europe. I've been there since 2011, so I'm pretty much a lifer. Building a lot of web stuff over there, just front to back, top to bottom, whatever. I guess you could, the full stack is the term these days. And yeah, and I do some facilitation and agile stuff there, and a little bit of tech advisory, which you would call the posted consulting thing, a little bit of that also on the side. Just really quickly, a few words about Features. I'm not going to bore you too much with this, but yeah, so Nordic company based in, founded in Helsinki, I think in 2001, in Tampere since 2009. We just turned 10 years over here. Bunch of offices all over, and a lot of people, a lot of different nationalities, a family of companies, a lot of like joint ventures with having to do with AI or e-commerce and things like that. Not a consultancy for just where you, hey, build me a website, more the kind where we put together a team and they work together with the client and they solve complicated problems in different domains. But yeah, I'm not gonna go too much into that. Sure, you can check us out on our website. Do you know what Heroku is? Who knows what Heroku is? Almost everybody. Well, that's nice. That's nice to hear. One of my favorite platforms. I guess you could say, well, I would describe it as arguably the simplest platform as a service. Runs on AWS and basically hides all the management of your infrastructure almost behind a simple command line tool and a nice web front end, where deploying an application is really almost as simple as git push Heroku master. So that is nice. You can think of it as containers. Everything boots every 24 hours. All storage is volatile, and yeah, starts your software starts in seconds. So it's a nice thing. And oh, sorry, yeah. So that's dynos. I was going to introduce these concepts, but sure many of you already know. There's also another concept, a key concept here that'll come up later in the talk, which is pipelines, which is Heroku's continuous integration or continuous deployment mechanism, where you have stages, code goes in one end, you promote it through onto production. And another nice feature of pipelines that it gives you is the ability to have review apps. So everyone knows what PRs are. Review apps are your instant copies of your application running code based on a PR, so a human can check them out. That is nice. And another key concept and a part of the Heroku ecosystem, if you will, is add-ons. So Heroku gives you compute, but pretty much everything else you bundle in there as add-ons. So if you want Postgres, you buy an add-on, and that is built through your Heroku account, but managed by a partner for you. And all the sort of ancillary services that you can imagine you can buy as Heroku add-ons automatically managed for you. And then just a few words about where we started. Let's take a look at what the sort of like the infrastructure starter looked like of the app. I'm not going to be able to talk too much about this actual service. It's just that it's a customer-facing self-service website, if you will, and built for a large Nordic company and used by people in the Nordics. Quite content heavy, and it's a React single-page application written in TypeScript, with a bunch of backends, those microservices, also written in TypeScript, and actually in production since just about New Year's in the new infrastructure that I'm going to describe. here's all the major components of it. So as I said, there's a nice front end that shows content that comes in from Contentful, which is a headless CMS. Through a microservice that we wrote to act as a cache over there. It's served from its own Heroku app. We were gonna front that with Cloudflare, but didn't have a need for that actually since we made this transition. And pipelines for like code review and stuff like that. Then and another component in there was Kong, which we had deployed as our API management component in Heroku, just due to it has all the features we want, and deploying it is like ultra simple. There's an actual deploy to Heroku button in the repository that will give you a working setup. A bunch of microservices separated by feature or by site section, if you will, and those were mostly to front existing backends, like legacy backends that the client already had that do all the boring stuff of making money. And then, yeah, the bunch of dependencies I already mentioned there, so things like user authentication and business logic. Here's a really high-level overview, again, of the system. So there's monitoring stuff, Papertrail, we really like Papertrail for logs, a bunch of microservices flowing through those pipelines, these backends over there, code going in through GitHub. Yeah, Travis is missing in this picture I see, but we have Travis for continuous integration and Contentful for content that the end users used. We actually really love this kind of setup, and yeah, I probably should mention at this point that this transition was actually the first Kubernetes project that I have ever done professionally, because this setup has served us pretty well in the past. Some really large Finnish websites that you might use run on Heroku in production, because the review apps are nice and you get the fast turnaround times and fast feedback times with those, and so there's no problem. And this costs $1,000 a month, just about, to run for this particular service. So there was 2 production grade dynos for everything basically, and I think around 4 microservices, yeah, something like that, and everything has stages, like at least staging and production. So that's about $1,000 per month. But then, as we were just about to go into production, actually last summer came the Colombo moment, or the one more thing, which is that now you actually have to run this in Azure instead. Now, I'm not endorsing Azure, which maybe is a nice point to underline here, but yeah, this was given to us as a requirement at that point. So, why did this happen? Maybe a couple of words just about that. Client already bought that, so there was an inertia to go there. They wanted to consolidate their infra expenditure, which I totally understand. Other than instead of me paying for Heroku with my company credit card as I did, it's nicer for the client to be able to invoice just for everything in their whole Azure infrastructure, and of course to have centralized access control, because we didn't have the sort of like the professional offering of Heroku where that would have been a thing. And well, why Kubernetes in Azure? Well, after hearing Jussi's presentation, maybe this part isn't as solid as it could be. But this was also sort of, as I said, we didn't have much experience about this stuff beforehand, so this was like half suggested to us. But it did have some nice things where it felt like a good fit. One of them was that we're actually already building Docker images just as part of our CI pipeline of all our microservices, because we wanted to run tests in Travis and we wanted to run them in a Heroku-like environment. So we pull in a Heroku base image, build stuff there, test that, but we just never used those images. We're just throwing them away. But now we're actually using that almost same build process to build images that we run in our cluster. And another nice thing about AKS specifically was that we liked that using this we were able to sort of course we want our infrastructure as code, as any reasonable person would, and with this we were able to have a sort of nice separation down the middle in that we write Terraform to spin up the AKS clusters and all the stuff related to that, but then everything else like deploying microservices, for example, is in Helm charts. So all the bits that are Azure specific stay in Terraform, and all the bits that are sort of generic are in Helm charts. And I don't know, I guess nobody sort of went through what Helm quite is still, but at this point you can just think of it as one more layer on top of kubectl, which is just abstracts away the some of the YAML stuff and allows for templating and things like that. So yeah, that's the tool that we use to deploy actual pods, deployments, services, and then Terraform is used to build the clusters, so we don't have to do that manually. And yeah, and we were always completely stateless, all our microservices. So container orchestration systems seem also, we wouldn't catch that flack, if you will, because distributed storage is like its own kind of set of problems, and now we don't have to deal with that. Mostly don't have to deal with that. So there's a couple of little places where that comes into play, actually quite recently. But yeah. This is perhaps a little bit more abstract than the picture I showed before, but this is sort of the kind of setup that we ended up building there. So some of this terminology now is Azure specific, but a lot of it isn't. So we still have our code flowing into GitHub, but just now, in addition to writing, for example, microservice code, our people also write Helm charts for those microservices to be able to deploy them automatically. In place of Travis, we now use Azure DevOps, which is Microsoft's CI/CD mechanism. It's a quite nice tool. One of the benefits is that it's quite simple to authenticate them with an Azure managed Kubernetes cluster and be able to just deploy stuff. And this is one of those like nice reasons maybe why you should rent. So you don't have to build that stuff yourself, but you just get that out of the box. We in Azure, well, there's of course a container registry where when we push code into GitHub and that gets built and tested, and images that pass tests they're stuffed into the container registry, and then except front end that goes into Azure blob storage, where kind of like S3 if you know it. So the website, the web front end, the static HTML is able to pull the app from there. We actually run separate production and staging clusters. I'm not sure if that's a good idea or not, or if that's an anti-pattern or not, but that is something that perhaps becomes easier again when you use this rented solution. So I'm sure we could use namespaces for separation, but it really doesn't matter to us. And having this strong separation between production and staging felt like a good idea to us, and so that's why we went that route. In our case, it's just one parameter to the Terraform, and we create one cluster or another. So again, it's like it's a cost that you don't have to pay. I'm going to show another diagram about the networking specifics in just a second, but we do have, there's an Azure API management thingy that fronts everything that actually runs in the clusters, which is what the web app calls out to. For monitoring, we also use an Azure tool. There's a thing called Log Analytics, which pretty automatically grabs everything that your pods output in the cluster, and you can search that and do all the nice stuff you want. For external communication to some legacy backends that are not on the public internet, some of them are, there's a thing called Express Routes, which is sort of like a VPN. You can think of it maybe as that way, or an IP tunnel or whatever. But still, I think that lets us talk to some packets that are cut off from the internet. So that's like really the 10,000 meter view into what that is. As for how the networking bits work in our particular setup, we already saw some examples or some slides about the pods and services. So we use, because as mentioned, the networking in Kubernetes is pluggable, we use the Azure advanced networking thing, which just means that all the pods end up on the same network as the nodes themselves, and so they're actually directly addressable from within Azure. And there's a thing in Azure called AKS HTTP application routing, which possibly could, I'm not quite sure because I haven't tried it yet, but I think it's a thing that sort of handles everything left from here. So all of the routing by path or whatever, there's a thing, again, a managed thing that can maybe do that for you. But we went this possibly more involved route where we have an English control, we have the Nginx English controller, which is just standard Kubernetes open source thing, and deployed into Azure, that is then coupled to a load balancer, which is outside the cluster, which is again an Azure thing. So another nice bit of productization that they give for you. We define services for all our microservices. So this is one microservice, this is another. And whereas in Heroku we had those multiple, we had duplication for all the microservices. Here, of course, we just have 3 pods per microservice. Everything is fronted by cluster IP service. There is an English per cluster where all of this is separated by URL path. There's a thing called cert manager, and just as a side note, all of this is like almost 100%, almost verbatim, just out of Azure's own documentation saying, yeah, this is how you should do that. That's the way we ended up doing it. Cert manager talks to Let's Encrypt, and what that does is it automatically provisions certificates for our English, so we can talk to that using HTTPS. And then in front of all of that, we have Azure's API management. Our microservices are written in a way using these 2 JavaScript frameworks or libraries called Happy and Joy, which are Happy is a routing framework, a web routing framework, and Joy is a sort of a validation library, if you will. And what that does is it allows all our microservices just to output open API specifications as standard. So we can just throw those into API management, and that automatically configures that. Almost automatically. There is still a manual step, something we'd like to automate in the future, so that when we release new versions that alter the way the API works, API management will get automatically updated. But that is still not there. But yeah. So how do we feel about this setup? One really nice thing about it that we really enjoy compared to Heroku is that we're not quite crystal clear on where our infrastructure is and where it runs, because okay, we sort of knew in Heroku, because in Heroku you say run this service in Europe or run it in the US, but when you pull in services as add-ons, extras, you also always have, because those are run by third parties, so we always have to vet those. How does this work? Where does this actually run if you're using processing customer data, especially now in the happy days of GDPR? One classic example of this is Heroku Postgres, although this actual project doesn't use that, but you can get a database and you can say this database is in the EU, but Postgres backups are always in the US, so that'll bite you in the ass if you're not careful. And logs are another thing. Where do your logs actually go? That might be a little bit opaque, but here of course completely control that with this setup. So that we think is a nice thing in this transition. Another thing in Heroku, oral secrets used to be just basically environment variables unencrypted. Well, you could encrypt them yourself, but then how do I get the key in? And then you have all that, those problems to solve. And now they're nicely stored as secrets and encrypted at rest. All Heroku services by default are on the internet, so now we sort of have a little bit of control over that. As I said, there's an enterprise offering that lets you have these private spaces that are not on the internet, but that costs about a lot of money, so we never went for that. Yeah, and Azure DevOps is actually quite nice in that you can do a lot of things with it, and there are a lot of possibilities in that. Well, that is not directly Kubernetes related, but still, you could have things like programmable phase gates between production and or staging and production, for example. Trigger this function, do something, and then come back, and if it's green, then it's green, and everything gets promoted onwards. But I'm afraid that client isn't quite ready for that, let's say, not ready for such a nice DevOpsy new modern life. Bad things, after having used Papertrail, which is really based on this large flow of logs that's easily searchable and you can do nice things with it, and just after that the log analytics thing is quite weird, and that takes a little bit of getting used to. We're now looking at maybe deploying an EFK or an elk stack also, just to grab our own logs and get that, just get the upside of things of looking at logs and looking at problems a little bit easier. Review apps, well, we still don't have those. There's a thing called dev spaces. I have no idea how that works, but it sounds like it would be a lot of work to get that same functionality as we have in Heroku. We actually cheat a little bit still, in that we deploy the front end, deployment version of the front end also into Heroku, so that we can get review apps that way. Infrastructure monitoring, you have to build that yourself, kind of, which is a bummer. Heroku is more productized in that you just kind of assume that stuff works. But here you do kind of have to take care of the cluster. But yeah, also gives you a nice bit of control. We are able to do fancy things like have pod readiness probes that sort of check external connectivity, and then do let the cluster do clever things because of that. Helm, I'm not sure I quite figured out Helm. What's the value out of that? We ended up just using it maybe for like small microservice cases. I don't know if it's worth the hassle. And then, yeah, I'm running out of time, but come ask me about Heroku Dyno recycling. I'll tell you a story about how missing that feature.
Yep. There are actually tools to do that on pods.
Sorry?
There are tools to do that on pods. I mean, recycles.
Oh yeah, okay. Sounds good. You should have told me 3 months ago. Yeah.
What was it you were wondering whether it's a good or bad practice?
I forgot already. What was I talking?
Having different clusters for staging and production.
Yeah, that was
yeah.
one thing I was
I think that's really common, and I would definitely see that as a good thing, because I mean, you're not, at the end of the day, you're not going to have one cluster. You're going to have a lot. So from the beginning, treating your clusters again like cattle in the analogy will make it way easier for you to go through the Kubernetes journey.
Yeah.
So
yeah. So about the move, just to give you like a ballpark, I think I looked at our reporting, and I think the move from Heroku into Kubernetes took about like 3 person months to do. So it's not like super cheap. And this is like none of the feature work is included that might have been done during that. It's just everything, all the meeting different people and verifying like connectivity. Now that all the infrastructure runs in a different place, we still need that connectivity to the external vendors of the third service applications, and just like everything, just about that much. As for how much it costs to run, happily ignorant of that. I don't have the permission to see the see the billing, but I don't know. Yeah, but hey, that was that. Thank you a lot for listening. I think I still have like maybe I don't. I'm 30 seconds over time. Oh. But yeah, come ask me later if you have any questions about this.
Grab a beer or whatever. And we'll continue in a short.
time for the last one. I try to keep it short because it's already over 8 o'clock. Yeah, I think the topic I have it quite fits to the continuum, or probably this is somehow bit the same stuff that Ilkka just presented. But to give you some context, I just want to present myself so that, because I'm a kind of infra guy. When I started, I started with Linux, and the Linux was Slackware. Then I did FreeBSD. Then I did everything in the hard way, and I'm still climbing up. In the way climbing up, I did some OpenStack and all the interesting stuff. But in the end, what matters is the applications running on the top, and I'm finally realizing that. So slowly climbing up. So today, it's about CI/CD. As we know, the Kubernetes itself, it's not perfect, but it's really good. And in some sense, I would also say that all the infra stuff beneath, Kubernetes does a good job to abstract everything, and there are plugins. Of course, the storage is not easy, but in many ways, I think the Kubernetes there are many good things there, except storage, except probably some security things. But in any case, my today's rant is that this app side is not that easy. Because, for example, is there a single best way to containerize application? Maybe. Okay, is there then a good way to make it secure? Is there a well-defined best practice how to run containers securely? Maybe not. Okay, then when you run it securely, is there a good way to keep these containers patched? No. Or maybe the more important part is that, is it easy to integrate all these? Because we know that there are a lot of tools that does part of these. For example, only the containerization part is quite standardized, and how to run it on Kubernetes. But then when you start building the actual pipeline, it's not that easy. Or what do you think? Is there someone who thinks that everything is so clear? No, because we need the next presenter. Sorry. Okay. But yeah, but before continuing, just a quick question: how many of you have actually used Kubernetes? And by using, I mean run application on top of it. So maybe 1, 2, 3, 4, 5, 6. Is it about half? And we have about 40, bit over 40 people here.
That's really good.
Yeah. How about actually then installed Kubernetes like Jussi did? That's also quite good. So a bit less half.
I guess the next question would be that how many in production? I mean.
Oh yeah. Okay, we can take that one too. How many in production? 1, 2, 3, 4. Mm-hmm. Okay, that's nearly the same as
that's pretty good.
The install. Yeah, good one. So let's start from the easy part, because generally when you talk about CI/CD, it's okay. You have someone that codes, then he pushes it to Git. Then some Jenkins or similar will pick the code and compile it, and then there is some testing somewhere, and then it's pushed toward the Artifactory. Or that's the only picture I found. Docker Hub was not that easy to find. So some repository where to store the container, and finally it's pushed to Kubernetes. It's that simple. Yeah? Because at general level, it means that there is something okay, I split it into four parts. That there is the part where you code, then there is the build part, then is the testing, and finally the shipping or deploying. I left off maybe the fifth part, that is the actual monitoring, analyzing, and then you go back to code. But yeah, but then why it's hard? I think my approach is that, okay, when you do code, the trickiness is that there are tens of options. It's easy when you have a, let's say you have a pre-made, I mean you have an existing application or an existing pipeline, because you already have maybe all the tools maybe already here, and then you just need to get the repository, containerize the application, and push it to Kubernetes. But on general level, it's not that easy, because if you just want to get something from scratch or improve it, there are multiple options. For example, in this coding part, you can do it locally. It depends, are you going to test it on the local machine or not? So, because someone, for example, if you develop a traditional Java application, you run, for example, the unit tests or even the whole application locally. So that's a bit different approach than for example, the other one where you run Minikube on the local host. Then in the build part, are you going to build it locally, then push it to the pipeline, or are you going to build it at Jenkins, or are you even going to build it in the container cluster, so running Docker builds in the Kubernetes? And then in the testing, okay, where to do them? Are you going to, you need to decide, are you going to spin up a whole environment every time you test something in a system testing phase, and so on. And then the last one, okay, how to deploy. We already heard the term Helm, that's templating, that's one. Okay, you could do it using Ansible. And I've been working a lot with OpenShift, so you could use OpenShift tools like OpenShift templating or other templating mechanisms. This is I would say somehow the application layer, because next there are others, maybe something that is not that often discussed. For example, you have repositories somewhere, we didn't discuss about them. Then I mentioned how to keep things secure, so how to manage base images. There are a lot of ways. Are you going to manage it yourself? Do you pick Alpine? Do you pick Ubuntu? Security updates. Okay, when the security updates comes, is it the application team that does the update, or do you have a mechanism so that you just update one base image somewhere and the pipeline automatically updates the image, or it goes automatically to some testing phase without a software developer? And then the triggering is interesting part, because even there it depends on the tool how you're going to do it, and for example how to trigger the actual deployment. Is it something that is triggered? Are you going to, for example, is it the last part of your pipeline, or is it something that is triggered by the pipeline and it's another tool? Pipeline, about the pipeline, there's the pipeline code. That means that you need to have a way to, because nowadays of course you want to do everything by code, so you need to have a way to pipeline the code, or not codify the pipeline the other way around. And yeah, image versioning, you need to have you need to define the versioning. Is it, okay, probably it's not the latest you're going to use. When it goes on the pipeline, you need to define the versioning, how it is. And this varies between the projects, and you need to have your own practices. And then the secret management. When you just build a pipeline, you often don't think about what about recreating the environment when I recreate a new one, and so on. So my message is just that the pipeline part is not easy. As in Kubernetes, as I mentioned, I think that's quite nice and it's standardized, and our distributions are standardized because of the all the standardizing work. But when you go above the Kubernetes, it's not that. And as an example, I first pick the one, for example, the one I've been working with. This one is OpenShift, but okay. This just shows that in a Kubernetes you can do it in many ways, because OpenShift is just one kind of Kubernetes plus plus plus. For example, plus these BC, DC, IS, those are objects that are not in basic Kubernetes. And if you build such, you can say that, okay, this is Kubernetes pipeline, but it's still not, because it's using the opposite ones. But yeah, this is one example we did with the customer. And in this case, again, the angry coder pushes the code to Bitbucket. And in this case, it's using the OpenShift pipeline mechanism. It's a kind of serverless Jenkins. So you just put a Jenkins file in Kubernetes object, and then it manages the Jenkins. And even this Jenkins file is managed by another Jenkins file, but that's another story. But that's the arrow there. And then the Jenkins file starts actually build config, and this is a different way of doing builds. So if you, to my understanding, usually when you do Kubernetes, you build the Docker container or the image, to be precise, in the Jenkins file, in Jenkins or similar system. But in this BC, it's maybe more close to this new Knative build, where the build is done actually in the cluster. So that's something that Red Hat promotes and opposite. But that's a nice system, but different. And actually this build config then pushes it to Artifactory, the registry. And then we pick it back. The image stream is yet again another, it's an abstraction layer on top of Docker tags. So actually in this image stream it says that, okay, now if you're running version latest, then this latest is pointing actually the latest on Artifactory. So if you change the another one, you need to keep them in safe and keep them in sync, but it also adds another layer of security in a sense that even if you point to a external Docker hub, you still know that I'm running the version I was running a moment ago. And then the deployment config and secrets. And when we go to the next stage, QA and or prod and so forth, then we again go through Artifactory and image stream and so on. And I just want to underline these few objects just to show the why that I show the thing that why I originally started thinking about this is that, for example, in OpenShift there is no, or there wasn't, maybe it's not even today, there isn't a good way to manage deployments or secrets. I mean good way, I mean that you just put it somewhere and there is best practice how to deploy secrets in multiple environments. Or even, yeah, maybe the easy example is that if you do a change to the deployment, you want to increase the memory, for example, then you need a way to push it from stage to another. The change in deployment, that's another thing than the change in the application. Okay, you know, maybe the best answer currently is Helm. So you bundle Helm. You bundle the manifest that describes the application to Helm chart, and that's another artifact, for example, that you push forward. But yeah, that was the original thing I was thinking when I realized that this is not clear enough. And then I bumped into this. Jenkins X, this is a quite new project. It tries to make everything so simple. So you have one command JX where you type create cluster, and then it creates a namespace for you with every tool you need, Jenkins, main registry, start registry, so on. And it even creates repositories for you in GitHub that describes these environment namespaces, test namespace, production namespace. And when you import project, it automatically creates a GitHub repository for you, creates the pipeline, and when you push code, it follows the predefined pipeline. So the difference is that this model that takes or tries to take account everything. From if we go back to this list that we have these, okay, it doesn't yet, for example, manage secrets, but it will soon, and so on. But the problem with changing X, the practical, we did this with customer, and I wouldn't recommend it. I don't know if have anyone used. At least Santtu, have you?
Tried it.
Ah, yeah, that's using. Second one. Because, for example, some findings. Practically, there are a lot of things that are hard-coded to GitHub. So we tried to use another Git repository, then we just need to do workarounds to get it to point to the local repository. And generally it's too intrusive, so because that's a ready-made model, if you want to do something a bit differently, then it's not that easy. Or you just need to push it there and then do the changes on top of the thing you just installed. But of course this will evolve fast. But I don't know, currently maybe I'm very interested in this scaffold and so on. But yeah, I think we still have a few minutes because I would like to give a short slot for Santtu to present his own home project. That is, let's say that's a one more use case or case story around this CIC.
Yeah. Okay, so as Toni said, I'm actually talking about a hobby project instead of a customer project, and this is still one that has lots of actual users. Being a hobby project, we have a place where virtual machine capacity is basically free, but cloud services are not. So that kind of points us towards certain solutions I probably wouldn't deploy if I were being paid for it. So what we used to do here was deploy a kind of a traditional web server application written in Python and Django to a single virtual machine using Docker and Ansible, where every deployment causes 2 to 10 seconds of downtime. And you'd think that's a short while, but we are actually hitting that, and our real end users are hitting that and complaining about it loudly. So we already had a Jenkins deployment in place that was doing the Ansible and Docker dance. So what we did was to repurpose that to work in a Kubernetes environment. So, well, I hold the firm belief that it's a good idea to first build your container image and only then run your unit tests inside that container image, making you to test that container image as well. If it's okay, then it's pushed to a registry. This time, actually, it's a public repository in Docker Hub, so no private registry here. Then every time, on every deployment, we run migrations and idempotent setup scripts, and then, and only then, deploy the actual application. And I'm going to take a minute about the final step, the deploying of the application, in which we use declarative Kubernetes configuration. That's templated using a tool called Mrichen, which is actually written by me, and this is its first public release and launch. So, yeah. Hard or impossible to do list valued variables in Helm. making you kind of spell out all the loops yourself and having to care for indentation. Horrible. So what I did instead was to do templates within YAML using a native YAML construct called tags. So there you see, you don't see? Okay, no laser point. So those exclamation point vars there are those YAML constructs called tags, and what they do in this instance is simple variable replacement, except that these variables may hold any values in any JSON or YAML type. So we have a template, really simplified one here, but it's using two variables called image and environment. The environment is supposed to hold a list of environment variables. So how do we build it? Well, in a var file, we specify it like this, and in it we can still use variable replacements. This is evaluated, the template is evaluated from top down and kind of lazily. So even though we still leave that tag there undefined, then we can still define it later. And finally, we have a variable file for each environment, in this case, the production environment. And finally, we are still able to define some variables, albeit only string valued ones, from the command line. And pipe the thing to kubectl apply and hope nothing goes wrong. So there's Enrichment for you. It's a template engine that works within YAML and JSON. It's a pragmatic and powerful way to generate YAML and JSON, and variables in Enrichment can be of any YAML or JSON type, not just strings, and it makes all your indentation and quoting problems magically disappear. And the cool thing is top-down evaluation with dynamic scope. So those are URLs at the end of the slide. You can just Google for Enrichment and you'll probably hit it. So thanks. Any questions for Tony or myself?
Or if I first quickly end this show. So this talk was just a bit rant about the current state of, or not maybe the current state, but probably I'm a bit idealistic, and I would like to see that there is a well-defined best practice. This is how you run an application in Kubernetes with best practices. And we are not there yet. So I challenge you to show the best practice in the next meetup. Please.
You're going to get 50 of those.
Yeah, great.
Any volunteers?
So, yeah, as Santu said, maybe we have a time for a question or one, two. And then we have the free time. So what do you think? You see you have something?
So no questions for Tony or Santu? I guess not. So I guess it's a wrap for the official part.
Yeah.
So thanks for the Cybercom guys to sponsor the snacks and drinks and space. And then of course for Ilkka and again Cybercom guys for speaking. And thanks for joining, and I guess we'll try to organize something in a couple of months or so.
Do not forget Neptune, they are also sponsor of us.
Sorry?
Neptune, they are sponsor of us.
Yeah. It's already mentioned.
Okay.
You weren't here.
This is actually Sakari, so he's
Yeah.
also one of the organizers.
Hi.
So if you have any ideas, anything you wanna share to the group, just contact us and we'll set up something.
Yeah, at least if you have something, demos or something cool things that go on. Our plan is more or less go a little bit deeper than usually in meetups, because in the meetups we usually just check on the, okay, what is the Kubernetes and that kind of piece of cake stuff. But we will go to the deeper. But let's start from the not so deep.
Yes, and I'll just quickly mention some of the stuff that came up here in other presentations that I had it in other presentations that I didn't show. So in this early phase of a meetup, we and occasionally from every now and then in established meetups, we want to give you the kind of high level view of how the community works and what's out there, and so you can wrap around your head around it. So here is the Kubernetes architecture, and as Jussi also said, actually realizing how Kubernetes works under the hood will help you immensely when trying Kubernetes out, because otherwise it's going to be like this unexpected, oh, why does it do that? And even though you know that, you'll probably get such a moment.
Yeah, my service doesn't work.
Yeah. So on a high level, the heart of the system is the API server, and here all policies are applied, all like these syscalls, all YAMLs, everything's defined here. And then we have just a key value, single source of truth database that can, a TD that can be replicated in whatever way you want. But still with this setup, just the API server and the TD, this would just be a normal document store. With the controller manager, we actually get stuff happening. And here, this one that is reconciling all the time. Runs a lot of controller loops, make sure the actual state is the desired state. Once workloads spin up, we need something that can, something pluggable that can bind one workload, one pod, to a specific node in a cluster. And this is the job of the scheduler. Okay, so we've submitted as a user something to the API server. That has been stored into the database. The controller manager has gone ahead and said, oh, the user wanted 3 pods. And then the controller manager creates 3 pods. It's stored here. The scheduler noticed, oh, we have 3 unbound pods in the cluster. Then it goes ahead and schedules those there. Every node agent, which is called the kubelet, watches the API server and checks, do I have stuff to run? Well, this just got one. It receives the specification for this. It says to Docker or whatever container runtime using well-defined interfaces here. In this case, the container runtime interface. So whatever thing could implement the container runtime interface, and that will then run it. For example, Docker or Containerd or Rocket or whatever. And then that's propagated to the OS, obviously. But then the third-party networking layer will actually assign the IP for that pod, so that a pod here on this node can access a pod here using that that stable internal IP that the pod gets. So you can use an overlay, you can use physical networks to make this possible. Like Azure has its own thing, Weave is an overlay, there are many, many other projects. But just so you get this kind of more higher level picture and or architectural picture, this is super simplified. Like then we have there's a good presentation about from Tim Hockin, one of the founders of the project, where he has this kind of presentation or like architectural overview, and then he actually has the next slide is like what it really looks like, and then there's clutter all around because there's so many stuff you also use. But another way to look at it, and Jussi talked about this as well, is that you can look at the cluster on 3 different levels. And this is what I work on in C+ lifecycle, where we think about this stuff, how to install Kubernetes. First, we have some machines. These machines can be sourced from anywhere. Like it's a cloud, it's a whatever on-premises or hybrid or serverless, you name it. But you get some compute.
And once you have the compute, you want to install Kubernetes on this compute. So you use Kubedium locally, you execute Kubedium on your machine, and that stitches stuff together so you get this Kubernetes new, the new OS, the kernel, right? So you get the kernel, and once you have the kernel, you can start adding stuff on top, which gets to extensions. And there are a lot of, like, here's the money, if you want to know. The money is here, not here. That's why we built Kubedium, because, that's why Kubernetes exists as well. Because like, nobody wants to compete here, because this doesn't give you any money, this layer 2, and it's just something that needs to work. The extensions though, and the user interface and the user experience, that's what sells, and the integrations with all the other things. So it's here, a lot of stuff is happening, and it's here you're gonna care about, and whether you use Kubernetes or not is kind of, or whether you use Kubernetes directly or not is kind of, are you this high level, then you need something, that's built that thing, or is it just Kubernetes sufficient? So that's like another way of seeing it. And then this explains the difference between higher level tools like AKS, EKS, Container Sting, Kubespray, Kops, whatever. They all do the whole cluster. You say to Google Kubernetes engine, I want 3 masters, I want 5 nodes, and I want endless compute. And then Google goes ahead and does that. That's dealing with all this stuff. But if you want to roll it yourself, then these building blocks that exist as open source tools might help. So that's like the difference. Where in the community we're building blocks, and in CNCF the projects are building blocks. But there's always going to be these 75 vendors or whatever that are building the integrations between them. And that might save you money, that might not save you money. So that's just those clarifications. But yeah, we have like 20 minutes or so left. Yeah, thanks for coming.
Yeah, random chatting.
Yeah, yes please. And we have the swag table.